Evening, Umar. Am I audible?
Good evening, ma'am. Yes, ma'am.
Kindly turn on your camera.
Sure, ma'am.
Hello, Umar. How are you?
Fine, ma'am.
Okay. So, Umar, today we'll be starting with the first chapter of chemistry, that is matter in our surroundings. All right.
Okay, ma'am.
So, before starting, I want to know that have you studied this chapter? It's ongoing in your school?
Yes, ma'am. It's ongoing. We halfway finished the chapter.
We have.
We are halfway done this chapter.
Okay, halfway done. Okay, good. So, you must be aware of the introduction then, right?
No, mama. I was absent in the school.
Oh, okay, no problem. Sorry, one second. Okay, so we'll be starting with matter in our surroundings.
Yes.
I hope my screen and whatever I'm writing is clearly visible to you.
Yes, ma'am. It's clear.
So now to start with, what do you understand by matter?
Uh, Matter is a type of substance which has its own mass and it takes up some space in our surrounding. It's known as matter.
Okay, it takes some space.
Yes, ma'am.
Okay, so anything which occupies space. Okay, and there's one more thing you should add, has some mass. Okay, it's very important.
This one I told.
Okay, okay. My bad. I didn't heard. It's called matter. All right.
Okay, ma'am.
Now, example can be anything around you. This pen is a matter. You are a matter. The laptop on which I am teaching, you're studying is a matter, etc. Okay. Anything around
Okay, ma'am.
you which is taking up some sort of space and has any kind of mass, any amount of mass is called matter. Is it clear?
Yes, ma'am.
Okay. Now, if we talk about states of matter, then how many states of matter are there?
Liquid, solid, and gas.
Solids, liquids, and gas, right?
Yes, ma'am.
These are the three states of matter. Now, can you tell me two properties of each of these states? How do you differentiate these states?
Uh, a solid object is visible to naked eye and it has its own and it has a fixed shape. It has a fixed shape.
Okay, it has a fixed shape. Now you said one more thing, that solids are visible to naked eye. Can't you see
No,
liquids
that's
and
not true.
gases?
No, ma'am, that's not true.
Sorry?
Yes, ma'am, I told wrong. That is not true.
Yeah. Liquids are also visible, and gases, some gases also have some color, so they are also visible, right? Okay, so
Yes,
solids
ma'am.
have fixed shape. What about the shape of liquids?
Liquid sometimes has a no. Liquid does not have a fixed shape.
Okay, no fixed shape. Then how will you define the shape of a liquid?
The shape of liquid is always disturbed.
And by disturbed, you mean?
Like it's always not in a fixed shape. It's always in different shapes.
Yeah. So you can say that it takes up the shape of the object, shape of the vessel to be precise, in which it is kept, right?
Yes, ma'am.
If you keep it in a rectangular vessel, it will take that shape. If you keep it in a circular vessel, it will take that shape, correct? And what about
Yes, ma'am.
gases?
Gases also don't have a fixed shape.
Correct. No fixed shape again for gases. Okay. So this was about shape, the first property. What can be the second property of our three states of matter?
Not sure, ma'am.
Okay, no problem. First was shape. The next can be volume, right?
Yes, ma'am. Volume.
And same goes with
Mass.
all three, as it was in the case of shape. For solids, the volume is fixed. For liquids, the volume is not fixed. And again, for gases, it is not fixed. Correct?
Yes, ma'am.
Okay.
Ma'am, what about their mass?
Yeah. Mass is fixed
Yes, ma'am.
for all three states.
Ma'am, how is mass
Not,
fixed for
no,
gas?
no, not, yeah, yeah. Actually, I was going to say that. Sorry. It's not fixed for gases. I'll erase this. It's fixed for solids and liquids, but not for gases. Okay.
Okay, ma'am.
Now, when we talk about these three states, it's important to discuss about the particles, right? Solids, liquids,
Yes, ma'am.
gas. They are all made up of particles, right? So, these are the particles. Now, if you talk about solids, we know that solids have fixed shape. Why is that? Because these particles are closely packed with each other. Okay, so they are closely placed, very closely placed. They are very tightly packed in this definite shape. Okay, that is why we say that solids have a fixed shape, a definite shape. Now, if you talk about liquids, can you tell me what is the difference in arrangement of particles?
The molecules or the particles are like they have a different significant gap in between of them.
Yeah, they have a gap in between them. They are not very closely packed as solids, right? They have gap in
Yes,
between.
ma'am.
And what about gases?
And for gases, the particles are scattered away; they're not linked.
Very farly placed. Okay, correct? Now,
Yes, ma'am.
now these particles, we know that in terms of solids, they are very compactly packed. So, do they have space in between them?
No, ma'am.
Huh?
No, ma'am. They don't.
No. Solids don't have any space in between them. But what about liquids and gases?
Yes, ma'am. They have significant space in between them.
Yes, there is space in between the particles of liquids and gases. Correct?
Yes, ma'am.
Now, what happens? We'll take example. When you dissolve salt or sugar in water, what happens?
The salt diffuses with the water.
The salt,
The salts get dissolved in water.
yeah, when you mix salt or sugar in water, it gets completely mixed, right? It gets mixed, or you can say dissolved, and it completely disappears, right?
Yes, ma'am.
Now, where is this salt going? When you say that it is dissolved in water, where has it disappeared? Yes,
Yes, ma'am.
can you tell
The
me?
particles, yes, ma'am. The particles of salt or sugar which is dissolved in water gets mixed with the water particles.
That is correct. But where are they disappearing? How is this
Mm,
mixing taking place? See, what happens? We have salt particles. When you dissolve it in water, how are water particles placed? They have gaps in between,
yes,
right?
ma'am.
When you dissolve this salt in this water, these particles will take up this space in between. The gaps which are there in the particles of water, that will be filled by the particles of salt. And this solution will be formed. Clear?
Yes, ma'am.
Now, this is a further topic, but I'll just give you a brief about it. Salt and sugar are considered solutes. Water is the solvent. So anything which is being dissolved is a solute, and in which it is being dissolved is called a solvent. And the mix up of both solute and solvent is considered a solution. Clear?
Yes, ma'am.
Is it clear what is a solute, what is a solvent, what is a solution?
Yes, ma'am.
Okay. Water is also considered a universal solvent because it is used to dissolve almost everything. It dissolves almost every solute. Okay?
Okay, ma'am.
Okay. Now there's one more thing. These salt particles are getting dissolved in this liquid. So as I told you that where are the salt particles going? They are taking up the space which is present between the particles of the liquids, correct?
Yes, ma'am.
So that is why there is no increase in volume of this liquid, even after you're dissolving the salt. Volume will not be increased because where is the salt going? In between the gaps which were already present. It's not taking up any extra space. Clear?
Yes, ma'am.
Okay. Now there's one more thing, that these particles which are present in our surroundings are in a continuous motion. These particles are in a continuous motion, which means they are continuously moving. They are not still. Okay?
Okay, ma'am.
Now, how will you explain this movement of particles? Can you give me an example if you think of any?
Uh, the water moves because of the motion of its particles.
Um, the water moves because of the motion of particles. That is the property of fluidity. Correct. Water has this fluid consistency. That is why it's in moving state. But that's not what we mean here. That particles in our surrounding are moving. Water is fluid. So if you will, it keeps moving. It's not still. But what about the particles in the surrounding?
Not sure, ma'am.
Okay. So we'll take an example. When your mom cooks food or your dad cooks food, when the cooking takes place in the house, can you smell of it?
Yes, ma'am.
Yes. We get some sort of smell. Why is it happening?
Because of the movement of its particles.
Yes, because the food particles, the food that is being cooked, its particles are continuously moving in your surrounding. And by your surrounding, we mean that they are traveling from your kitchen to your dining room to the whole area of your house. Okay? Those particles are in
Uh,
a continuous motion. Correct?
yes, ma'am.
Okay. You want to ask something?
No, ma'am.
Okay. So if any question comes that how will you explain this phenomena that particles present in our surroundings are in a continuous motion, how will you explain this? So you can give this example that when the food is being cooked, the particles are in a continuous motion, and due to that motion of particles we can smell the food. Okay.
Okay, ma'am.
Now another example can be, have you heard of a chemical called potassium permanganate?
Yes, ma'am.
It's very dark purple in color, right?
Yes, ma'am.
So when you add one drop of this chemical in water, when this is added in water, the whole water turns purple, right?
Yes, ma'am.
Why? Without even mixing,
Uh,
this is happening.
ma'am, because of diffusion of particles of this potassium permanganate in water.
Correct. The particles again here are moving. The particles of potassium permanganate quickly travels and takes up the space between the particles of water, and the whole water turns purple. Clear?
Yes, ma'am.
So this can be another example of particles are in a continuous motion. Clear?
Yes, ma'am.
All right. Now, for today's class, we'll keep it till here only. For the rest of the class, I'll share one test with you. I'll share my screen. I'll open one test that will be very basic science test, just to check your previous the knowledge of your previous classes, right?
Okay, ma'am.
Yeah. Okay. Just give me 2 minutes. Yes, Umar, can you see my screen?
Yes, ma'am.
All right. So we have this test. So there are few MCQs, and then we'll come to the theoretical questions. Okay. Now the first question
Okay, ma'am.
is that which of the following is not a state of matter?
It's option C, light.
It's
Option C, light.
light. Okay. Next, what is the chemical formula for table salt?
It is in AOH. Option D.
Okay, you said NaOH. Option D. Okay. What is the chemical symbol for water?
It's option B, H2O.
H2O. Okay. Next, which of the following elements is a metal?
It should be carbon.
Okay. Next, which of the following is a non-metal?
Uh, it is it is calcium, ma'am.
Okay. What is the chemical formula for oxygen gas?
It is O2.
Okay. What is the process of conversion of water vapor into liquid water called?
It is evaporation. Option A.
Okay. Next, which gas is produced when a metal reacts with an acid?
Carbon dioxide.
Okay. Next, we have four theoretical questions. First, explain the difference between physical and chemical changes, providing examples of each.
Uh, Not sure, ma'am.
Okay, not sure. Next, define the term matter and provide examples of different states of matter.
Uh, a matter is a substance which has its own mass and which occupies space in our environment is known as matter.
Okay,
That
space.
there
Okay,
there are three types of matters. There are types of matters that are that there are three states of matters that are liquids, solid, and gas. For liquid, for example, liquids are water. For solid are metal, and for gas is oxygen.
correct. Next, describe the structure of an atom, including the subatomic particles and their charges. Can you describe the structure of an atom?
I think this is not in our syllabus, ma'am, for last year.
Okay. Okay. Why do solid wave high melting point? Okay, there's some typing error, I think.
Ma'am, the question number 12 and 11, they were not in our syllabus. As for previous class, we used some guides to study for each class, that's why.
Okay. All right. Okay. Now just give me 1 minute. Okay.
Okay, ma'am.
Yes. Sorry, Umar. I just want to ask you that from this was just a diagnostic test, just a basic test. So, do you have any doubt in any of these questions apart from those
Uh,
which you did not have in your previous classes?
yes, ma'am. Some questions.
Yeah, please go ahead.
Some questions like question number 4.
Okay, so what we'll do is we'll review the whole test. So, which of the following is not a state of matter? That's light, correct? What is the chemical formula of table salt? That's not NaOH, it's NaCl. Okay,
Okay, ma'am.
so that's correct. This one's incorrect. What is the chemical symbol for water? H2O. Again, that's correct. Okay, which of the following elements is a metal? Just 1 second, please.
Okay, ma'am.
Yeah. So, which of the following elements is a metal? So, you had a doubt in this only.
Yes, ma'am.
Okay, what's the doubt? You're not sure of the answer that you gave?
I'm not. Yes, ma'am.
Okay. Yeah, it's incorrect because it's not carbon, it's sodium. Out of oxygen, carbon, sodium, and chlorine, sodium is the one that is a metal. All other three are non-metals. Clear?
Yes, ma'am.
Okay. So you are not sure of your answer?
Yes, ma'am.
Okay, no issues. Next we have which of the following is a non-metal? Are you sure of calcium?
No, ma'am. Not calcium.
Then,
I thought of carbon first.
but you had given carbon as the previous answer.
Yes, ma'am. That's why I choose calcium.
Yeah, correct. It's carbon. Carbon is a non-metal here. Okay.
Okay, ma'am.
If this sort of confusion arises, so you can change your answers. Okay. That ma'am, I thought it was carbon in the previous question, but I think the carbon is the answer of this question. You please change? Okay, just let me know.
Okay, ma'am.
Okay, what is the chemical formula of oxygen gas? O2. You sure?
Yes, ma'am. Very sure.
Correct. Next, what is the process of conversion of water vapor into liquid water called? Can you please tell me this? What is the state of water vapor and liquid
Can
water?
you repeat again, ma'am?
Can you tell me what are the states of matter for these two things? Water vapor is in which state? Liquid water is in which state?
Liquid water is in a state of fluids, and water vapor is in a state of gas vapor.
Gases and liquids, correct? So when you convert a gas into liquid, what is this process called?
Oh, I read the question wrong, ma'am.
You?
I read the question wrong.
Okay, so you think it's
It's
not evaporation?
no, ma'am. It's condensation.
Correct. You can take time to read your answer, okay? To read the options to understand what the question is asking you. Okay?
Okay, ma'am.
You knew the answers, but you just gave them in a hurry without thinking twice, right? Otherwise, you know the
Yes, ma'am.
answers. Okay. Which gas is produced when a metal reacts with an acid?
It's carbon dioxide.
No, it's hydrogen gas. Okay?
Okay, ma'am.
When a metal reacts with an acid. Okay. So we can take an example here. I'll give you one example. HCl, hydrochloric acid, is an acid, right? It's
Yes, ma'am.
reacting with a metal called sodium, which is Na, correct? So when an acid
Yes, ma'am.
reacts with a metal, a displacement reaction will take place. This this chlorine will get attached with Na, that is sodium. So it will form NaCl, that is salt. Okay? And this hydrogen gas will be separated. Okay?
Okay, ma'am.
This is a very basic equation of what happens when an acid reacts with metal, hydrogen gas is released. Clear?
Yes, ma'am.
Okay, next. Explain the difference between physical and chemical changes. Provide examples of each. So you're not sure of this?
No, ma'am, I forgot.
Okay. Now, what happens when we talk about a physical change? When we say that a physical change has taken place in anything, then it does not change its properties. The substance's properties are not changed. It remains the same. This we are talking about a physical change. Are you noting now?
Yes, ma'am.
Are you noting this down?
No, ma'am.
Okay, then please pay attention on the screen.
Okay, ma'am.
Okay, now in physical change, the properties of a substance remains unchanged or remains same. For example, when ice melts, it forms water. So properties are same only, right? It's just that the state is changed. Correct?
Yes, ma'am.
The identity is not changed. Only the state is changed. But if we talk about a chemical change, then the identity of the substance is completely changed. Identity or property, please pay attention on the screen
Ma'am,
of,
I'm noting because it's
okay,
important.
of the substance is changed and a new product is formed. Something new only is formed. Okay? So the
Okay, ma'am.
example can be when, have you heard of iron rust?
Yes, ma'am.
So when iron catches rust, then a layer is formed outside that iron substance, iron thing. That blackish brownish layer is formed, right?
Yes, ma'am.
It is the layer of iron oxide, the oxides, not iron oxide. That layer is called oxide. So this is a chemical change because iron, when undergoes rusting, it changes into iron oxide. It changes into oxides of iron. Okay. So
Okay,
this is
ma'am.
a chemical change because a whole new thing is formed here. Iron oxide. That's a new product which is obtained. And the properties of the previous one has changed. Changed properties. Clear?
Yes, ma'am.
Okay. Next, the question we had was define the term matter and provide examples of different states of matter. So you said that anything which occupies space has some mass is called matter. Three states you gave me: solids, liquids, and gases. Now, what are the examples? You said that solids can be metals. Are you sure all metals are in solid form? Go with
No,
a
ma'am.
very basic thing. Solid, a pen, ice, right? Go with basic examples that surrounds you. Okay?
Okay, ma'am.
Liquid can be water, correct? Gas is oxygen, correct? Clear?
Yes, ma'am.
Okay. Now you didn't attempt the next two questions, but we'll still discuss them. Okay? Describe the structure of an atom, including subatomic particles and their charges. What do you understand by an atom?
Uh,
You,
Atom is it's like the smallest it's like a type of micro matter inside of the cells in your body.
the smallest unit of matter. Okay?
Okay,
That's
ma'am.
atoms. Now, subatomic means something which is at a lower level than the atoms. Sub means a part of atom, right? So subatomic
Yes,
means
ma'am.
there are certain more elements which are present inside the atom. So they are called subatomic particles.
Ma'am, I have a doubt.
Yeah,
You said that atom is the smallest unit of matter, right?
yeah.
But I don't think it's the smallest matter of unit of matter.
Okay, because it has subatomic particles.
Yes, ma'am. Like neutron, proton, and electrons.
Okay, see, actually, these are the three consisting units, the three things that combine and form an atom, right? So technically you are saying the right thing, your doubt is correct. Okay, that atom is also made up of something, so how can you say that it is the smallest unit of matter? Correct, but smallest means you have, see, you have a rock or you have an ice block, you're breaking it down into smaller pieces. Now, once you will reach at that stage that there is one very small, very tiny particle which you cannot break any further. Indivisible, because it cannot be broken any further. That is why we say that it is the smallest unit of matter or smallest unit, sorry, particle. Okay?
Okay, ma'am.
Because you cannot divide it any further, although it is made up of certain few more things which are called subatomic particles. But we consider it the smallest unit because you can't divide it any further. Clear?
Yes, ma'am.
Now, what are these subatomic particles? These are protons, neutrons, and electrons. So there are three subatomic particles: protons, neutrons, and electrons. And you also had to tell the charge that they possess, right?
Yes, ma'am.
Can you tell me the charges?
Ma'am, about charges. Ma'am, it should be positive.
Which one is positive?
Electron is positive.
No. See, P protons, P positive. So protons are positive. Okay. And electrons are negative. Now neutrons are neutral. Neutral means there is no charge. Okay. There is no
Yes,
charge
ma'am.
on neutrons. Clear?
Yes, ma'am.
Okay. Next. What was the next question? Why do solids have, okay, this is not wave, this is have. Why do solids have high melting and boiling points? Okay. Now, what do you understand by? We'll break down this question. Melting points and boiling points. What do you understand by melting point and a boiling point?
Melting point means like at the point where the metal starts to break apart.
Don't specify any substance, anything. Melting point is specific for different substances, right? So
Yes,
don't
ma'am.
name a specific substance, like you said, metals. Any solid, when
Yes,
you
ma'am.
melt it, there will be a certain temperature at which it will start to melt. That temperature will be called its melting point, right?
Yes, ma'am.
You have a block of ice. The block, if you will heat it, if you will provide heat to the block of ice, it will start melting at a certain point. Okay, so that is called a melting point. Similarly, for any metal, if you start melting any metal like aluminium, it will melt only after a certain amount of heat has been already provided to it. So that is a melting point. So any now say the definition. You saying it right?
Any solid system which has a, or which has a certain melting point, and is any solid system which has a melting which has the ma'am, I don't know how to explain this.
No, no, I understand. See, you know the concept. You're not able to put it into words, right?
Yes, ma'am.
The temperature at which any substance, don't specify the substance, no solid, no metal, no ice, any substance, okay, starts to melt. Okay, that is called its melting point. Clear?
Yes, ma'am.
Now, if we talk about the boiling point will be what? The temperature at which any substance starts to boil. Clear? Clear?
Yes, ma'am. But ma'am, how can solid substance boil?
Yeah. See, solids, if you provide heat to the solid, it will break down, it will convert into liquid. And then when more heat is provided, that liquid will start to boil. Okay?
Okay, ma'am.
Yeah. Now, why do solids have high melting and boiling points? When you are melting something, when you're providing heat to melt that substance, what is that heat doing? It is breaking down the particles of that substance, right? When the particles will break, the substance will distort, it will leave its original shape and it will convert into other, some sort of liquid to melt, right? So solids
Yes, ma'am.
have high melting point because solids have strong intermolecular forces. We discussed it earlier that solids, the particles of solids are very compactly packed, very closely packed, right? So when you
Yes, ma'am.
place something very close, it's the force of attraction between the particles is very high. That is why they are attracted to each other so much. They are placed close, right? Because the force of attraction
Yes,
is
ma'am.
high. And when the force of attraction is high, the more strong the glue is, more hard, more energy it will take you'll apply to separate it, right?
Yes, ma'am.
Similarly, when the force of attraction is high, more heat will be provided to break them apart. Yes or no?
Yes, ma'am.
That is why solids have high melting point and high boiling point, because of the intermolecular forces between the solid particles is very strong. Okay, and it takes
Okay, ma'am.
more energy to break them. More energy is needed to break them apart. Clear?
Yes, ma'am.
Is it clear now?
Yes, ma'am.
Now, this energy is applied in both the cases, for melting also, for boiling also. Okay?
Okay, ma'am.
All right. So, with this, we have completed the test paper. Now, you can ask your doubts if there are any from today's class, from the theory part and the test part.
Ma'am, I only have one doubt.
Sorry?
Ma'am, I only have one doubt.
Yeah, please ask.
You said that every substance has a melting and boiling point. But wood is also a solid substance, but it does not melt either. It does not boil.
I didn't say that every solid substance has a melting and a boiling point. I was talking, I see, that's why I didn't specify, right? I told you also not to specify. I wrote any substance. Any substance which can melt or which can boil has a certain melting and a certain boiling point. Not all.
Okay, ma'am.
Okay? You can't melt wood. You can burn it. You can convert it into ash, right?
Yes, ma'am.
Yeah, you can't melt it. Okay?
Okay, ma'am.
All right. Any other question?
No, ma'am.
Okay. All right. So today we'll end the class here and we'll continue with the chapter in the next session. I
Okay,
hope you
ma'am.
were able to understand everything in today's class.
Yes, ma'am. And yes, ma'am, I forgot to mention that I got my test results for class 8 finally.
You got the test results.
Yes, ma'am, for final
Okay,
exam, 80 class.
how was it?
It was perfect, ma'am, because I got 79 out of 80 in science.
Oh, that's great. And what's the overall percentage?
Overall was 99 out of 100.
Overall percentage.
Overall percentage, it was 97%.
That's great. It's a brilliant performance. Very good. Congratulations.